Visit us at EduVo. Thank you for calling EduVo.
Let us write a program to find the sum of first n natural numbers. Though there is a formula available for it, but instead of that we will take a loop and add them. So what I want is, I want the numbers 1 plus 2 plus 3 plus 4 up to n, whatever the number is, I want to add them. So actually there is a formula, but we will add them one by one. So here I want to know what is n. So I will declare a variable n and I will say cout, enter a number. Then cin, I will take a number. Now what I want is, one by one the value should be changed, incremented, and it should be added to sum. So I should have one variable sum, and I should have one variable counter, that is I. So what I want is, initially sum is 0. Now this is 1. So 1 should be added, 0 plus 1, and that result should be stored in this one. Then 2 should be added to this. So 1 plus 2 is 3, and this 3 should be stored in sum. Then this becomes 3. So this 3 plus this 3 should be added, and the result is 6. It should be stored in sum. Then this becomes 4. So 6 plus 4 should be added, and the result 10 should be stored in sum. So in this way we can go on changing this value one by one and go on adding it to sum. So how it is being added? So this is sum plus I, and the result 10, where we are storing it? Inside 10, sum only again. So this should be stored in sum again. So this is the statement by which we can go on adding a number one by one into sum and get the sum of n numbers. So for this I need one variable sum, and let its initial value be 0. Now how this repeatedly sum can be done? Using for loop. So for integer I assign 1, I is less than equal to n I plus plus, and here every time I should do is sum assign sum plus I, and outside this display sum. Let me show you how it works by taking a small value. Suppose n is 5. So what are the values I have? N, sum, and I. N is 5, and I have sum and I. See, initially sum is 0, then I is 1. So what is happening here? Sum assign sum plus I. So 0 plus 1, 1 is stored here. The next time I becomes 2. So 2. Then enters inside, it is less than or equal to 5. So sum assign sum plus I. So 1 plus 2 is 3. So this becomes 3, and next I becomes I plus plus. So I becomes 3. Then 3 is less than 5. Then sum assign sum plus I. These two are added. Result is stored here. The next I plus plus, I becomes 4. Then 4 is less than or equal to 5. Yes, enters inside. Then sum assign sum plus I. So this is 10. 10 is stored here. Then I becomes 5. Then 15 is stored here. I becomes 6. So 6 is not less than or equal to 5. So it will stop. And the result is 15. So this is how sum of first and natural numbers are printed. Let us write few programs using loop. Here I want to write a program for displaying a multiplication table for a given number. Suppose the number is 5, then I want the output on the screen should be 5 multiplied by 1 is 5, and 5 multiplied by 2 is 10, 5 multiplied by 3 is 15, so go on. So in this, if you observe, this is the number that I want, and this 1, 2, 3, 4 up to 10 if I am going, this is like a counter. So counter, we know we can use I. So I need the number and I want a counter, and this statement should be go on printing, so I need a loop. A repetition is there, so I need a loop. Let us write the code here. I will have some variable, let us say n, then I will say cout, enter a number. Then cin, I will take a number n. So n is taken. So n may be 5. So if it is 5, the table will be for 5. If it is 7, the table will be for 7. Then for I assign, integer I assign 1, I is less than or equal to 10. I want this counter to start from 1, 2, 3 up to 10. Then I plus plus. So this loop will be repeating for 10 times. So in this, what I want the display should be like this. So C out n, and after that x, this acts as a multiplication operator. It looks like multiplication on the screen. Then next is 1, 2, 3. So who is taking the values 1, 2, 3? I. Then next is product of these two, that is 5 into 2 or 5 into 3. So this is n into I, and then and l. That's it. This is a simple program for displaying multiplication table for a given number. I will write few more programs, but one thing I would like to tell you that, see, this is the formality. I have to include and declare namespace. We know it well that it must be there in the program. I will not be writing it because I will get some extra free space for writing the code. So I will avoid writing these things from next code onwards. Let us write a program for finding the factorial of a given number. What does it mean by factorial? See, if I want to find out 5 factorial, it is 1 into 2 into 3 into 4 into 5. So the numbers are multiplied from 1 through 5, whatever the value of n is. So if n is a 5, then 5 factorial we want to find out. So how this can be done? So 1, then again 2 is multiplied with that, then 3 is multiplied. So this is like a counter. So again I need something that is I, which will be taking the values 1, 2, 3, 4, so on. Right? Then every time I should multiply it and store the result somewhere. So I will take one variable fact, and in that I will keep it as 1. So let us do it like this. 1 into 1, result is 1 only. Then this 1 into 2, result is 2. Then 2 into 3, result is 6. Then 6 into 4, result is 24. Then 24 into 5, the result is 120. So every time this factorial is calculated by multiplying the value of this factorial into I. So we get the new result. So value of this factorial is multiplied with I and store the result in factorial. So this is the expression or the equation. So this is the expression we are getting for finding the factorial, and this is repeating, you see. So I can use a for loop for repeatedly performing these operations. So here already I have the piece of code for taking a number, then I need one more variable, that is factorial, and initially it should be 1. Now using for loop where integer I starts from value 1 and I is less than equal to n, I plus plus. Then each time factorial is factorial into I. Then C out factorial. So already I have done the tracing part here, and based on that I have written the code. Now one important thing. See how I am solving the problem. I am taking some approach and solving the problem. Now students feel difficulty here when any task is given, they cannot write the code for it, and they feel that they are not getting the logic, means they are not getting the approach for doing it. So how do you get this approach? How to get the factorial? What should be the approach? So based on the approach only the code is given. So this approach comes with practice only. So more and more problems, if you the same problem you do it multiple times, you get some more new idea by yourself, right? Suddenly you cannot develop a program for some complex thing. So you have to practice the same program again and again. You should be able to write it by yourself. If you are at that stage, then you get a new idea that let us try to change this value and see what happens, that value and what happens. So you can play around with the code afterwards. Loops is the core part of programming where you actually write the logic of your application. So this is more important. This needs a lot of practice. If you are new, first time you are doing programming, then spend more time in these programs. Watch it and write the program. Later you do it by yourself. This will help you grow your skills, programming skills. Let us write a program to find the factors of a given number. See, suppose I have a number that is 12, then I want to know all the factors. So how we actually check is, first we will try to divide this 12 by 1. It gets divided exactly by 1. So it's a factor. Then we will try it by 2. So 12 will get divided by 2 exactly without leaving any remainder. So yes, 2 is also factor. 3, yes, 3 is also factor. So if any number is dividing this 12 or a given number exactly without any remainder, then it's a factor. So suppose I have a number. Now how to write it as a program? So what we will do is we will take a number, then This number 12, we will go on dividing it by 1 and 2 and 3 and so on. So 12 divided by 1, then there should not be any remainder. So actually for remainder, it's not division, it is mod operation. So if I am getting 12 mod 1 as 0, then 1 is a factor. Then 12 mod 2 is 0, then 2 is a factor. 12 mod 3 is 0, so 3 is a factor. 12 mod 4 is 0, 4 is a factor. 12 mod 5 is not equal to 0, it is 1, so it is not a factor. So with every number we will be going on dividing it, and if it is exactly dividing and the remainder is 0, that is a factor. So this is a number given, and this is 1, 2, 3, 4, 5, this is like a counter. So here already I have a code for reading a number from the keyboard, then using a for loop I will take counter integer I assign 1, and I will go up to the number only. You can stop before also, but I am going up to number. Then every time what I will do is I will check if this number mod I is 0. If it is 0, then I will display a number that is dividing it I and L. This is a program for displaying all the factors of a number.